Alrighty, here we go. We're going to learn some basic Swift 4. And this is just a short overview of what you're about to learn. Now, Swift 4 is obviously Apple's shiny new language for creating apps on all their devices and on macOS. And as you might guess, it's now in its fourth version. And before that, we actually had Swift 3.2.1 going back in time. And the original, of course, was Objective-C. Now, if you've worked with Objective-C, you'll know that Swift is a lot easier to use and understand, and mostly easier to read. Now, it's important to know that Swift 4 is mostly compatible with Swift 3. So if you have an existing project in Swift 3, you can create different frameworks in Swift 4, and you can mix and match the two, and you can sort of migrate each framework up to Swift 4 from Swift 3, one at a time, to check that everything works. There are a few exceptions, and we're going to note those as we learn throughout this course, but I'm not going to concentrate on it too much because you're here to learn Swift 4 and obviously not Swift 3. Now, Apple has promised that this is stable now, and since Swift 3, the changes are only minor. So if you're sort of familiar with Swift 3, you should be good to go. Now, getting down to the meat and veg of the matter, what we're actually going to learn in this section are the basic Swift 4 concepts. Concepts such as variables. Where do we store data in our programs? We'll look at loops going round and round, arrays where we store sets of data. We'll look at functions, classes, and how to organize them. We'll also look at objects, which are created from classes. And if you don't know what that means, it doesn't matter because I'm going to show you. We'll look at operators and inheritance, and probably a few more as I continue to develop this section. Now, what's important for you guys to know is that when you know these things and a few others, then you're good to go with any object-oriented language. You just have to learn how that different language likes to construct its items and its particular syntax and language. So the good news is, by learning Swift 4, you're already becoming a multi-tooled programmer. Right, so by the time we're done here, you are going to have a great Swift toolset, and that's going to give you the ability to start creating your very own apps. Welcome back. Now, obviously, we don't want to start learning to code from the context of within an app we're creating. It's kind of a horrible way to do it because you have to recompile the app every time you want to test your code. A much better way to do it, and this is a fantastic Xcode feature, is to use playgrounds. Playgrounds allow you to mess around with the programming syntax and structure and discover what's happening immediately. Playgrounds are a little bit limited. You can't do everything in them, but they are perfect for what we need to do. So open up your Xcode beta or Xcode 9 if you're watching this when it's released, and follow along with what I'm doing. Right, with your Xcode beta open, simply click Get Started with a new playground. It's the first option in that menu. If this screen doesn't appear because maybe you clicked this button by accident, simply go to File, New, and Playground, or hit that key combination. And once it loads up, it asks you, do you want to do iOS, tvOS, or macOS? Well, obviously we want iOS, but in reality, there's not a lot of difference between them when it comes to playgrounds, as long as we're keeping it simple. So we can have a blank one, a game, a map, of single view. I think we'll just go for blank. And when you do that, it asks you where you want to save it, so I'll just save that on my desktop. It may ask you if you want to enable developer mode, so go ahead and enable that. Put your password in if it requests that. And there we have our playground up and running. Now, if you excuse me for a second, I'm just going to improve this font size so you guys can see it better. Right, with your Xcode beta open, simply click Get Started with a new playground. It's the first option in that menu. If this screen doesn't appear because maybe you clicked this button by accident, simply go to File, New, and Playground, or hit that key combination. And once it loads up, it asks you, do you want to do iOS, tvOS, or macOS? well, obviously we want iOS, but in reality, there's not a lot of difference between them when it comes to playgrounds, as long as we're keeping it simple. So we can have a blank one, a game, a map of single view. I think we'll just go for blank. And when you do that, it asks you where you want to save it, so I'll just save that on my desktop. It may ask you if you want to enable developer mode, so go ahead and enable that. Put your password in if it requests that. And there we have our playground up and running. Now, if you excuse me for a second, I'm just going to improve this font size so you guys can see it better. And there we have it. Our playground is up and running. Now, I want to draw your attention to just a couple of things before we go on to the actual next lesson. The first thing is, this at the top here is in green. That's because this is a comment. A comment normally starts with 2 forward slashes. There are other ways of making comments, but 2 forward slashes is the standard way, or the quickest way. A comment isn't processed by your program, so your program completely ignores them, and when your program compiles itself, the comments don't get included. Below that, any line that doesn't have any commenting double slashes before it is a bit of code. So, to understand what these 2 lines are doing, let's move on to the next lesson. So, building block number 1. These are variables. Variables are the little bits of data that make up your program, your app, whatever you are coding for. They are the things that hold the little bits of data like strings, and a string is just, say, a word or a letter or a character. They hold numbers, and there are different kinds of numbers, integer, floats, etc. Don't worry about what that means now. I'm going to take you through it nice and simply. But more importantly, I want you to understand that a variable can be anything. Anything can be stored inside of the variable. So I want you to think of a variable as a little box, and inside that box, we've put something data related or something related to our program so that we know where it is, and we know what it is, and we know what kind of thing it is later on when we need to use it. So that's enough preamble. Let's open up an Xcode playground and follow along with what I'm doing. Right, here we have our little playground. Now, we're going to talk about variables. So for now, we're going to ignore this first line. I will come back to that in due course. We are going to look at primarily this line, var str equals hello playground. Now, the first thing to note is on the left-hand side, we have this word var. Var is simply shorthand for variable. Now, normally, we have to say in a programming language what kind of variable we want to store. And in this case, the kind of variable we're storing is called a string. A string is simply a collection of letters, numbers, characters. So you might be asking, how does Xcode know that this is a string? Well, it's clever enough to figure out because you've put a couple of quotes around your variable, Xcode infers that you have a string. So var is just kind of a shortcut that a lot of programmers use. Now, if you want to make it really obvious that this is a string, all you have to do is put a colon and then type string after var str. And that tells Xcode this is definitely a string. So if we look at this now and I try to type something like my name without the quotes, Xcode will get an error and it will say expected initial value after equals. We'll get into what that means sooner or later. But this is an error. It's going to go wrong. So I'm just going to undo that by hitting Command Z so we have our original string on screen. Right. What's important to note is that once we've created this variable and we've assigned a type to it, type is just the type of variable that it is, then we cannot easily change the type, and nor do we ever really want to. That would be a very bad programming practice if you tried to do things like that. So this str is forever a string. And that means that I can refer to an str down here just by typing it. And if I scroll down to Xcode's autocomplete, it tells me str is a type of string. And if I just leave that there, you'll notice over in the right-hand side, let me just expand this. And it appears I cannot expand it quite enough. But we can see what we need to see. It tells us the str is hello playground. So this is what a playground does for us. It sort of lets us do the code on the left and gives us the result on the right. So it's good for learning. Now, if we have an str, it's a variable, and variable implies that this thing can vary. So I can say str is equal to, and I can give this a new string. Grant. So I've changed what's stored inside of str. And if I just type str below there, notice that it prints out the new variable. The old one is gone. There is no undo when it comes to programming. Bear that in mind. You cannot get your old variable back. Well, unless you're a programming god, of course, but I think even that's difficult. Right, so in programming, we use a lot of numbers. How do we store a number? Well, one option, crazily, is we can store a number as a string. But be careful, because any programming language doesn't know that that is actually a number. It just sees a string. It doesn't sort of make that extraction or that jump that we as humans make. We say that is the number 2 and not the string 2. Programming is not like that. So if we want to actually store a number, we need a variable to store it. So I can say var mynum is equal to 7. And Xcode will store that as the number 7. And notice there are no quotes around that. If you put quotes, it'll make a string. So now if I type down here mynum, it comes up with our autocomplete and says this is an integer. An integer is simply a whole number, 1, 2, 3, 4, 5, 6, 7, 8, etc. And integers do have a maximum value, which is something you need to be aware of, but much later on. And an integer cannot store a decimal value, because if we try that, 7.4, and we specifically make this a type of integer, whoops, let me just correct that, 7.4, we have an error. So it's trying to do this decimal and put it into the integer, but that simply doesn't work. So how do we take care of decimals? Well, there are actually 2 ways of doing that. The first way is to use a float. And you'll see there are several floats here, float, 32 and 64. 32 and 64 refer to the type of computer or the processor that your operating system is running on. Don't worry about that for now. So our float is able to store 7.4. But what if I want to have a really long number that ends in lots of 8s? Let's see what happens. What's happened here? It's truncated it. So a float can only store a much shorter decimal. What happens if we want to store a longer one? Well, we use double to do that. And a double allows you to store the whole thing. So now we have everything here, and if we click this little I over on the right, it tells us the whole value. It's still not the complete picture, but it is a lot better than the simple float version. So it's much more accurate. Now, that's important because let's say you're making a banking app and you're transferring money or something and you're converting from currencies. That decimal point, I think it stops somewhere about there, could be quite important for your calculations. What if you had a trading app? That would be extremely important for knowing your margins. So those are 3 different types: string, integer, double, float. That's 4 types. The final one in this lesson is called a Boolean. Now, Booleans are very, very useful. Var myBool of type Boolean, which is just short as bool, is equal to, and this can take one of 2 values, either true, something is true, let Xcode catch up, or something is false. Yes or no answer. Now, Booleans come in very handy when we're checking the state of our program or the state of any received data or stuff like that. It'll become obvious as we progress through these lessons. So those are the basics, real basics of variables. And just before we go, we can have var any variable, and this can be of type anything. And this is going to give me an error because we don't have anything as a type yet. But we can set that as whatever we need to. So remember, the basic rule is a variable is simply a container or a box to hold a specific type of information. Right? That's done. Let's move on and look at the next topic in Swift 4. Moving on from variables, we have collections. And the first type of collection we have in Swift, there are roughly 3 that you will generally use. The first lot of these are called arrays. Now, an array stores a whole collection of variables, as you might guess, and it stores these in an ordered list. So I might have some strings that say 6 eggs, milk, flour, baking powder, and bananas. And then these are all indexed. So in Swift, we start our indexes at 0, going upwards until we've reached the end of our array. So an index of 0 means that is the very first element inside of our array. That's important to remember. Arrays are what we call 0 indexed. That means the first element starts at index 0 and not 1. That will catch you out if you are a beginner quite a few times. Still gets me out very occasionally. Okay, let's open up an Xcode playground and implement some of these arrays in our playground and see what they can do. Right, with your playground open, let's create an array of integers. So, as with variables, we start with the keyword var, and then we give this array a name, some ints. And we are going to make this equal to, and here we have the universal language for an array in pretty much every programming language. And that is 2 square brackets. And then inside of those square brackets, we specify the type of array, which is integer. And then we need to add one more thing to this, and that is what we call initializer. So I'm going to add an open and close bracket. And what that does is it creates the array for us, which currently has nothing inside us. Inside us. Has nothing inside of it. There is nothing in that array. There are no elements. So that's how we create a simple array. So how do we create an array of strings? Well, that's pretty simple. Some strings is equal to the same syntax, except we specify that this array is full of the type string. Now, what if we wanted to add a value to these arrays? Well, these arrays come with what's called a method. And the method does all the heavy lifting for you to add the thing that you want to add. So, for example, if we come up here and we say some ints, and if you notice on the right-hand side, this will have nothing inside it. That's expected. We can add something by using append. And notice what comes up. It says void append new element integer. So that new element integer says, give me the integer that you want to add to this. So if we hit enter, it auto-completes. If you hit enter again, it auto-completes integer, but we don't need that. We can remove that, and we can add an integer, let's say the number 8. And now, we now have the number 8 added to our array. Now, there's another way we can actually add integers to this. So we can say some ints, and this is a programming shorthand. We can say plus equals, and that means it should add what's about to come up on the right-hand side to our integer array. So all we have to do is open a square bracket, drop in the number 4, and close that square bracket. And now SumInts has two members, 8 and 4. So you could keep doing this forever and ever. And this is pretty useful when you're going round and round a loop and you're adding arrays according to whatever logic you have in your program. Of course, we can do exactly the same for some strings. We can say dot append, and we can add our new element. We can also have some strings, and we can have plus equals, open and close our square brackets, and we can put the abbreviation of my last name. So now our string array contains 2 items. But notice what happens if I try to add a number, the number 7. I would expect an error because the array can only carry one type of variable. So we obviously cannot do this. Now, obviously, we don't want to add arrays one by one. So just remove this line. We can actually add multiple variables to our array. So I can add pasta here and wine because I just had some at lunch. There we go. We had some pasta and wine. Great. So that's a nice handy shortcut. Obviously, you can initialize your array when you first declare it. So up here under var SumStrings, what I'm going to do is I'm going to say this is an array of strings, and I'm going to make it equal to, I'm going to delete these 2 brackets and put 2 square brackets. So this is very similar to this syntax, except up here we're initializing it. We're creating the SumStrings variable. So in here I can say, what have we got? Pizza. I must be hungry. I'm writing all these things down. Barbecue. And now we have an array created with pizza and barbecue. And later on, those values get added to our array down here. So I can check them out in this little explorer on the side. Great, so that's how you handle sorting them out. But something else you're going to have to do many times is count how many things are inside of an array. And that's important when you go around loops, because sometimes you'll get data and you won't know how many elements there are. So you have to count it. So let's have SumStrings dot and start to type count. And you'll notice it gives you count, which returns an integer. That's what the left-hand side of that little autocomplete means. It's going to give you back a whole number, because obviously you can't have half an element. Our count will show up on the right-hand side. There are 6 elements in this array. Perfect. Right, so you know how many elements are in there, but let's say we have our array here and we want to grab element number 2, which, if you remember, is actually element number 3 because we start counting at 0. So how do we get that? Well, that's, again, simple enough. We can have SumStrings. We open a square bracket, and we give it the index of the thing that we want, which is element number 2. And we close our square bracket. And that returns back to us grunt, as we expect. Now, here's a little tricky bit. If I go beyond 1, 2, 3, 4, if I try to access number 5, look what happens. It doesn't exist. Or does it? Hang on a second. 2, 3, 4, 5. Oh, I think it does exist. Whoops. Let's try go for number 8. And we should have, there we go. We have an error. Actually, I'm wondering, oh, of course, we have 6 elements, don't we? Because we have 1, 2, 3, 4, 5, 6. Okay, so number 8 doesn't exist. And so we get an error, a horrible error. And this is one that's going to get you out quite a few times. But there are practical ways of avoiding that completely. So as you develop as a developer, if you'll pardon the pun, then that error will kind of disappear. So Whatever you do, don't try and access an array outside of what we call its bounds. Its bounds are the minimum and maximum of the array. Obviously, you can never access element -1 because it just doesn't make any sense, and you can't access element 8. Okay, now those are very basic arrays, and there are tons more things you can do, but we'll learn that as we go. So far, we've looked at arrays in our little collections, and the next thing we're going to look at are sets. Now, if you recall, in arrays, we store things in an ordered value. So we add something, it's at index 0, we add another thing, it's at index 1, etc. Sets are different to arrays. Sets actually store distinct values, all of the same type, within a collection. By distinct, I mean you cannot have the same item twice. So if you had a set of integers, you could not have the number 2 in 2 entries. Whereas with arrays, you can have it as many times as you like. Sets also do not order your items. So you cannot say, I want the item at place 0 in my set, because that simply doesn't work. It's not what they're designed for. So if I give you an example, if we have music types and we want to store them in a set, but we wanted to make sure we never repeated one of the music types twice, we'd have something like this: rock, jazz, classical, hip hop. If we tried to add hip hop to this set again, it wouldn't show up, it wouldn't be added, and we'd be left just with the single value of hip hop. That way we can ensure that something never gets repeated. And that is pretty useful when we come down to more complex programming. It helps get rid of a lot of the filtering and the checking that we need to do and makes your programs run much more slickly. Okay, so let's create a couple sets by opening up a playground and following along. Right, let's create a set of letters. Var letters is equal to what? Well, as you might guess, our type is of set. But we have a set, it doesn't know what it's going to store. So the way we tell it is by opening up this triangular bracket and telling it we're going to store some strings. And then, of course, we have to initialize it. So open and close your brackets. And now we have an empty set. Now, unlike an array, we don't append anything, because append means we add it to the end. And because a set has no order, there is no end. Instead, we're going to get letters, dot, and we are going to insert the letter A. Now, just before we go on, this is a fantastic thing that Swift has done, and all the guys developing Swift have created. They've made it very language-based as a programming language, which sounds a bit more idiotic, but what I mean is everything means what it does. So insert means it's just putting it in there. There is no order attached to that. If you had append, like you do with arrays, that means add it to the end. So the guys at Swift are very hot on having the correct language for what you're doing, and it helps avoid a lot of errors. Right, let's move on with our sets. We can initialize sets just like we can with any other kind of variable. So let's have var faves or favorites, and we can tell it this is a set of strings. And then we can, of course, create that set, and we can have our pizza, our wine, and of course our pasta. Right, so Swift knows that this is a string or a set of strings because we have told it. But we could actually also remove this string, and Swift knows we've specified strings. It knows we've said set, so we can do that. Be warned though, if you remove set, Swift is going to turn this into an array. And notice here, we have a square bracket. Whereas, if we keep that set in, we will have curly braces. That's an important thing to remember. Now, sets can, of course, use a lot of methods. So if I get my faves and I just put a dot, it tells me what I can get out of it. I can have the capacity of it. Don't worry about that for now. I can count. I can find a member with contains. So quite similar to arrays, really, just with that key difference of no repeats and no order. So just to demonstrate the no order, if I get my faves and I add pizza to it twice, well, what do you think is going to happen here? If I inspect it, I only have 3 elements. And that's because pizza simply gets removed if it's repeated. So you've got to be careful with that. Whereas if it's an array and we explore that, we have 4 elements in total. And I'm just scrolling up and down with the mouse wheel because you can do that. Okay, so let's undo that and just get our set. So obviously someone has eaten my second pizza, which is probably good for my diet when we have a set. Right, let's move on to the next one. The final collection we'll look at is called a dictionary. Now, dictionaries are very useful, but they can also be quite confusing for beginners and experienced developers alike. It's quite easy to kind of get lost in them when you're trying to sort out a data structure. Before we get into the things that could trap you, let's look at what a dictionary actually is. A dictionary is just like a dictionary you'd pick up at a bookstore. It stores associations between keys and values. And obviously, that's just kind of like a standard dictionary. So if we look at an example of airports, our dictionary would look like this. We would have an array of keys, YYZ for Toronto, Dub for Dublin, LHR for London, Heathrow. And inside of those keys, we would have values associated with them. I shouldn't say inside of them, I should say associated, because they're not actually inside. But those values we would pull out by asking our dictionary, I have this key called Dub, what does that mean? What's the value of it? And our dictionary would produce the value associated at that key. Now, keys are of one type and values are of another type. In this case, keys would be strings, values would be strings. Sometimes your keys could be integers and your values could be strings, or the other way around. But generally speaking, they tend to be strings and strings, or integers and strings, or even integers and arrays for values, etc., etc. So you can make any data structure you like, and you can see what I mean. It can get a bit confusing. So before it gets confusing, let's create our own dictionaries and see how to do these the very simple way. So open up your playground and let's create a dictionary. Let's begin by creating a comment, so // Now, dictionaries are defined in the following way. We have the dictionary declaration itself, and then we have the key and the value that goes with it. So that's how we define the type called dictionary. So let's try that. Let's have var names of integers. And let's make this a dictionary. Open your triangular brace. And let's make the keys of this as integers. And let's make the values as strings. And then we can actually initialize this to its first set of values, or just leave it empty. So the way we do that is by opening a square brace, have an integer, and then a semicolon, string, and our usual open and close brackets. So now we have created an empty dictionary. Now you'll notice, first of all, and this annoys me, that here we have a comma to represent the 2 elements, but over here we have that semicolon. It's a bit inconsistent if you ask me, and I wish Apple or the guys that make Swift would actually change that, but hey ho, that's what it is. Technically, you don't need this, because Xcode will pick up it's a dictionary. So if we undo that, we will have our dictionary back as we made it. Now, how do we add values to this? Well, let's get our names of ints. And what we want to do is we want to grab one of the keys. So this key is an integer. It could be a number, 7. It could be 5. It could be 87. Whatever it is, it doesn't matter. So let's make this 2. So we're grabbing this key at 2, which doesn't actually exist yet, but we're about to make it exist by typing equals, and then typing the word 2, which is a string. So now our dictionary has one value. If we look up the index or the key of 2, we will come out with a string of 2. So let's add another one, names of ints, and let's put something at 9 is equal to 9. So now we have 2 elements in our dictionary. And we could go like this forever and ever. But when we want to get them out, we want to say names of ints, and then give me the element at index or key number 2. And if you look over on the right-hand side, once it's caught up, it says the number, or rather the string 2. So that's a dictionary. Now, maybe it's quite difficult to see how that's useful now, but as we continue with programming, you'll see it will become more and more useful when you want to order quite complex sets of data. Now, one final thing before we go, and that is, how do we make different types in our dictionary, and particularly, how do we specify arrays? Well, that's simple enough. I'm just going to delete this. And I'm going to say that this is going to be an array of strings. So every time I have a key integer, next to that integer, I will have a whole bunch of strings that I can pull out. So that's difficult to just think about from words. So let's create that in actual programming. Names of ints. Let's get 2 is equal to. Now it's expecting a string array. So we can't just have 2 because it will complain. So you can see that red mark up there, doesn't like it one bit. And actually down here, it tells us what is wrong with our code. My playground cannot assign value of type string to type string array. So it doesn't like us mixing the 2. We need to put this in an array. An array of 1 element is fine. You can always have that. We can add different translations, like dva, and that's Bulgarian for 2. Probably an horrendous Roman spelling of it, but you get the point. 2, dva. We can add some French, de, and now we have 3 elements. So if I try to access names of ints for the index of 2, we will get on the right 2 dva 2, and it tells us what we have. What if we want to access one of those strings? Well, we can access array number 1, maybe, or maybe not. So it tells us string has no subscript members names of ints 2, 1. Now, if you look here, we have a string and question mark. It's telling us that I don't think you might not have something here, because it doesn't really know in advance what we have. Or it does, but it doesn't want to tell us. So what you have to do is put a question mark here. And this is sort of a Swift concept, this question mark. Something I'll cover by itself because it's quite a large topic of optionals. That's what it's called. And I'll cover this later on. But it says if you can access element number 2, then try and access number 1. So it prevents us from getting some horrendous error when we access something that's not within the bounds, just like arrays, if you remember. Right, so that's the long and short on dictionaries. Let's move on. Let's look at a very important concept in Swift and programming in general. If-else or switch case. These two things do more or less the same functionality. So in programming, you might have a variable and you might want to check what its value is. So you will say, if it equals this, then do something. Else, if it equals something else, then do something else. And the story is much the same with switch case. So it's not too difficult to grab the concept of this. So open up Playgrounds and follow along. Right, let's start with something nice and simple. Let's have a var called mynum, which is just going to be a simple integer with a value of 33. Now, how do we test if the value is 33? Because let's say we want to send someone some kind of birthday card, depending on our program, and if their age is only 32, we don't want to send it yet, but as soon as they turn to 33, we might want to send it. So what we need then is an if statement. We'll say if, open bracket, mynum is, and here's the tricky bit, equals equals. There are two equals signs, 33. And this is called a comparison operator. So it's just comparing the two sides. It's not setting one as the other. Then once you've done that, if this is true, we open a curly brace and Swift automatically closes the curly brace. So if mynum is 33, then it's going to execute whatever is inside of these curly braces. If it's not 33, it won't execute it. So let's print mynum. And we should see that over on the right-hand side. It has printed it. Now, print is simply a command to, as it sort of implies, to print something out. And that's why it's come out as a string. It's got quotes around it. And it's got this \n, which means create a new line. Don't worry about that for now. The important thing is we've printed out this value of 33. Whoops. Okay, so it is 33. But what if I put 32 in my initialization? Well, this doesn't actually get executed. So it doesn't show up on the right-hand side. Let's set it as 33. Okay, let's say we want to test for various different numbers. Let's say else if, open your brackets, mynum is, and you don't just have to have equals to, you can have greater than 33. Then we can print something like old man. So what our program does, this is the logic flow of it, it checks if it's 33. If it is, it prints it. And then it doesn't bother checking anything else. That's why we have this word else. It's only going to do this if that is not true. So it doesn't do old man. So if I put 34 in here, we should get the else statement printed out, but not the first one printed. So it's skipped over this because it's not true, but this one is, so it'll do that. Okay. Now what if we don't have 33 or 34? Well, we can cover all the other scenarios by simply having else. We don't have to have if. So if our program goes and checks this one and it doesn't work, checks this one and it's not true, then it will go to this final one and it will execute it. You don't have to have this final else, just so you know. But if you want something to execute regardless of the value, then we're going to print it. So let's print young man. Okay, so if I have the value of 30 here, we should get young man printed out. Excellent. So you can see what I've done here. I've covered all the eventualities for what my number could be. It's either equal to 33 or it's greater than 33. And what's left after you've been through those two? Well, it can only be less than 33, which is else. So the other way I could have done this, I could have said else if mynum is less than 33. And that would give me exactly the same result. That would cover everything. Now, of course, this starts to look a little convoluted. What if we wanted to search for 30, 31, 32, 33, 34? You can see how this would get kind of unwieldy and unreadable. So the alternative to if-else is called Switchcase. I'm just going to make a little room here. And this works like this. We switch my_num. And then we open curly braces, and Swift will close them for us. Then we say to it, if you have a case where my_num is 33, then I want you to print my_num. Like so. And then we can have another case where my_num is between 0, ... and is less than 33. And for that, we can print young. And finally, we can have a case for when we're older than 33, but rather than doing that and just simply inverting that sign, we're going to have the equivalent of an else statement, which in Switchcase is actually called default. So this is the thing it'll do if it finds no other things to do. Print old. So let Xcode catch up with us. I obviously program faster than Xcode. And it tells us we have young man in both cases. So if I put 99, hopefully we have an old man and old. So those two, the if-else and the switch case, are very important concepts in programming. We're going to use them a lot, and you'll just get used to them, to be honest, because we're going to use them so much, it'll just become second nature to you. Right, on to the next one. So far, we've looked at collections of things like arrays. What if you wanted to go through an array and you wanted to pull out each variable one by one and perform some kind of programming action on it? Well, the way to do that is to run it through a loop. And there are several kinds of loops, each with different syntax, that differ very slightly from each other, or in fact, some of them are actually the same as far as we will be using them. So let's discover what these loops look like by opening up a playground and following along. Let's say we want to create a loop that goes around 10 times. For that, we would actually use that word I just said, which is for. We would say for variable I, and this I could be named anything, it doesn't have to be I, in, and we want to go from a count of 0 to 10. So what this is going to do, it's going to go round this loop 10 times. And each time it goes round, it is going to add 1 to I. So let's print I. Let's see what comes out there. Well, it says 10 times. If we inspect it, it says 9, and that is the current value of I. And if you recall our arrays, we always start counting everything from 0, generally speaking in programming. So I is 0, it goes round, I is 1, I is 2, until we get I is less than 10. Not equal to, but less. And what's less than 10 in integer world? That's number 9. So that's our very first basic loop. Now, I just want to show you something because I'm going to help you avoid wasting a lot of time here. If you go searching for loops on the web and you see something like var I is equal to 0, semicolon, I is less than 10, I plus plus. Functionally, this is the same. However, in Swift 4, this has now been removed, this syntax. So error, C star statement has been removed in Swift 3. I didn't know it was gone in 3. Could have sworn they said it was going to be 4. Anyway, that will not work in Swift 4. So when you find your posts with a bit of code you need to use that in place of that, and you'll save hours of frustration. Right, let's look at how we use loops in arrays. So let's create a var numbers, which we will actually specify as an integer array, and this will be equal to whatever numbers you feel like putting into it. So we've got 5 elements in that array. In order to loop through that, all we have to do is say for var n, and that n could be called anything, of course, in numbers, and then we want to print out n. So what's this doing? Well, it's grabbing this array, and automatically it knows you want to loop through it. So it grabs the first one, the first time round, it loops through, grabs the second one, third one, fourth one, and fifth one. And it just saves you from having to type the longhand way of the for var I in 0 to 10. Okay, so that's a simple way of getting all the elements and doing something. And you can imagine you would do a different kind of processing here, and this would make it very simple and very compact to program in order to loop through an array. And the major advantage here, right, this is important. The major advantage, you don't need to know how long this array is, how many elements it has. Remember back to an earlier lesson, we tried to access an element in the array that actually wasn't there, and we got an error. If you do that in your apps, they will crash, and it will be a bad user experience. You'll get a 1-star review, and they're not great. I know from experience. So the beauty of a for loop is you don't need to know in advance the size of the array. The for loop will stop at the end without falling off the cliff. Right, the next kind of loop we have is the while loop. So this is a bit more tricky. Let's create a var count variable, which will be an integer, and that will be equal to 0. Okay, now, while that count is less than 10, we are going to keep executing this loop. We'll call it print not yet. Now, if you've programmed before, you know what mistake I've just made here. Look how it keeps counting up and up and up. It's just going round and round that loop. Because count is always 0. And I've said, as long as it's less than 10, keep doing this. And this is called being stuck in an infinite loop. And again, it will cause iOS to kill your program for you, or at the very best, your program will be non-responsive and sluggish. So the way to get out of this is to add 1 to I each time we go around. So after we printed that, let's have I plus equals 1. And let's see what happens. We have a slight error. So what I'm going to do is just cut this because I think it's actually crashed like I promised it would. And then I'm just going to paste it again once Xcode is caught up with itself. It keeps trying to print out not yet at the bottom, as you can see. Oh, wow, this is going crazy. Well, it's a good demonstration, isn't it, of what can actually go wrong with these things. I'll tell you what, I'll just switch off the video now and let this run, and I'll let you know in a minute how long it took. So that took much longer, and I had to force quit Xcode because it wasn't responding. So you've seen the danger. I'm going to paste this back in, and now that we're adding I each time, whoops, not I, that's silly, isn't it? It's count plus equals 1. I'm still stuck in the for loop, if you like. And that should go round 10 times once it has finished thinking about it. So if I just drag my little window at the bottom up, we should see not yet printed out roughly, or exactly, 10 times. And there we have it. Right, so that's all good. Now, another warning, you might see some other shorthand for adding. And this is plus plus. And this is wrong because it has been removed from Swift. So again, that's another thing that could actually get you out. Let's put that back to plus equals 1. Make sure it's there so I don't get a crash again. Okay, so that's the while. Now there's a slight variation on while called repeat while. And they don't sound too different, and functionally they're not, but when you come to programming, you'll understand the nuances between them. So let's just try that. Let's have a repeat. So we're going to tell it to repeat something called print not yet count plus equals 1. So it's going to repeat something, but it tells us I expect a while after the repeat statement because we haven't given it a condition to stop running yet. So we're going to repeat that while the count is less than 10. And you can see this will go round 10 times and then stop. And there we have it. Now, it's not obvious how different this is to the previous one. In fact, it seems like more code for no good reason. But later on, we'll discover there are some fairly good reasons for doing this. Okay, that's the end of loops. So far, we haven't really organized our code in the playground very efficiently. But that doesn't really matter because we've only had very small snippets. But when we come to program real stuff, we can't have just one big block. So what we're going to learn about is how functions allow us to organize the code better and more efficiently so we can read it, other people can read it, and it just helps organize your brain in a brain mappy kind of way so you understand what's going on after a few months when you haven't looked at your code. Rather than having a big spaghetti mess, you'll have neat little functions. So open up Playgrounds and let's look at how to do that. Right, so a central tenet of a function is so that we can organize our code, but also they exist so that we don't have to write code twice. Here's a little tip. If you ever find yourself writing code twice when you're programming, stop what you're doing and reorganize it. You should never write code twice. So let's look at how a function helps us avoid that problem. We define a function by typing the word func. And of course, Swift is telling us I expect an identifier in the function declaration. That, in English, simply means I want you to give this a name. So let's call this function check count. Open and close brackets, and that signifies that this is a function. You might also call this a method. Different languages slightly call them different things. So C# you would call it a method. Open our curly brace and close it. Now all of the code we're going to put inside of here belongs to this function, and the code won't execute unless we call this function, and we'll see how to do that in a bit. But for now, let's write some code. Let's say var count, we should be used to this by now, int is equal to 0, and let's create our repeat loop. This is good practice for us. We want to print not yet, and we're going to add 1 to our count. And don't forget, this comes with a while the count is less than something. Right, so we have our function. So what's happened? Well, nothing's happened because this code will not execute by itself unless we call this function. And calling a function is pretty easy. All we have to do is type check count, open and close brackets, and it will fire that function once. Notice how it's fired out our not yet's 10 times. Now that's a bit difficult to see, so what we'll do is we'll reduce this to 3. So it will fire that 3 times. That's easy to count. Okay, and then underneath there, we might put a print done and put a lot of dots so we can see that clearly. So we should have some not yet's and a done. Right, so that function has fired once, and that's brilliant. We could actually fire that again somewhere else. Check count. Now watch what happens. It's fired twice. So you can see by having our code stored away in this function, we can access it easily by simply calling the name of the function. But that's not even the best thing about functions yet. Let's remove this one. Let's drop that a bit. Functions, inside of these two brackets here, we can pass over a piece of data, and that data could actually be anything that we want to pass over. So let's tell our function we're going to give it a message. And this message is of type string. So it's got this string. Now, if we look down here where we call check count, it says we're missing an argument for parameter message and call. An argument is simply what that is called. These are called arguments. I don't know why. If someone can tell me, please do. And it's telling us we haven't actually sent anything over, and that's what our check count is expecting. So what do? Well, let's send it over. Message, not yet. Now we've passed over this not yet message. So it goes here, it gets passed over here. Now we can use it. Instead of printing not yet, we can simply print the message. And that gives us the same result. So we're passing data over to the function. And of course, we can run that with whatever message we feel like, and it will print that out. So I hope you can start to see the advantages of functions. Now, we don't actually have to just send one argument. We can send as many as we like, although I'd advise against sending tons and tons, because that means your program is not well structured. But for now, let's send 2. Let's send over an integer, which we will, of course, call count. And let's say 9. And we should get an error. It tells us we don't actually have that because we haven't implemented it up here. So let's do that. Count as an integer. Now we will use this count to tell us how many times to do the loop. So first of all, we have a conflict. So this count cannot be the same name as this count. That is actually a problem. So what we'll do is we will change the name of this one to end count. And we'll change it here. End count. So you've got to be careful with those clashes sometimes. So now our end count we can put down here. Instead of 3, we just drop in end count. And this will go round the number of times we specify in end count. Look at that. It's gone round 9 times. If I said go round twice, I think you can guess what's going to happen. Right. So what else are we going to talk about here? We're actually going to talk about the names. These names should be descriptive, but also as short as you can make them. So we don't want check count of the hot dogs in stand, because that's, well, it's just ridiculous. So you would just have check count. You might have check count hot dogs or count hot dogs. And that's probably a better one. We can have count hot dogs or whatever it is. So you should make it short, but as descriptive as you can within that. Right, now there's one other thing that we should cover in functions. Well, there are tons, but we're only going to cover one basic. A function can give you something back, which is referred to as a return value. So let's say we wanted to send over a message once we were finished here. We need to tell our function that it's going to send back, and this is dash, triangular bracket. We tell it what we're sending back. We're going to send back a string. Now, hopefully we should get an error because it says we're missing return in a function expected to return string. And that's saying you've told me you're going to return this, but you haven't actually given me anything to return. So what we're going to do, instead of doing print done, we're going to return our string, and that could be whatever we need. We can say completed. Now, completed won't print down here in our little inspector thing, but completed will print here, as we can see here. So we've returned a string once our function has finished. This is an important concept because when you go off, say, to your server, you grab some data in your function, eventually you're going to return that to your main program. And this is more or less how you're going to do it. It's not the only way, there are many other ways, but this is the basic way of doing it. Now, because we're returning a variable, we can actually assign it as a var. Var result equals completed, and then result itself is a string, which is completed. So that's how we can get variables back, right? That's the very basics of functions sorted. Optionals. This is a fairly new thing to most programmers, but it's a great feature of Swift 4. Now, occasionally, and this is the reason we need optionals, occasionally we need to have a variable that we don't write to immediately, so it doesn't have a value. We might actually write to it later on, though. And in most programming languages, this actually causes two main problems. One, if nothing is stored, then we get what's called a null reference. And that simply means there's nothing stored inside it. Now, if we try to access that, it's going to give us a crash at runtime in most other languages. Swift's a bit different. That means your whole app will crash. That's it, dead, over. And obviously, that's not good. So, that's the first problem. But the second problem is related to the first one in that we need to actually add more code to check the variable is there. And you can imagine with a lot of variables, this code could actually add up and cause other problems of its own. Now, Swift does away with these problems quite elegantly, but it's a bit confusing at first because of how they've constructed it. So, open up a playground and let's have a look at how to use optionals. Right, let's create a variable called myString, and let's give it a type of string. And let's see what Xcode says about this. Xcode seems to be okay so far. Great. Now let's print myString. There we go, we have an error. So variable myString is used before being initialized. That means there's no value in it, and that's going to cause us an horrendous error. So Swift won't let you do this, and it's clever enough that before we release our program, it says, hey dude, you might actually have an error here, so please fix it, okay? Other programming languages aren't so hot on this yet, but they are changing. I believe F# is actually changing towards this sort of paradigm. Now, if I put a question mark after this string, what I'm saying is there might actually be a string inside of my string. And if this works, let me just try and hover. No, it doesn't work. If I just type my string here, notice how the type changes to string question mark. That's important to know because that means it's an optional. Now, what's the difference between that and that? Well, the first one, the type is a string. The second one, the type is an optional. So that's important to realize the difference there. The first one, it's a string. The second one, it's optional. So in the second one, we're saying, here's a box. It's an optional box, and it might contain a string. But it's up to you to check if that string is in the box. So let's go ahead and do that. Let's say if let my string value is equal to my string. So what we've said here is if let. If we can create a variable called myStringValue from something inside of that box, then, and only then, are we going to do something with myStringValue. So we could print myStringValue. And hopefully that's not going to print. And there you go. Right, so I hope that's clear. And by the way, let is just another way of creating a variable, same as var. There is a difference, but we'll get to that in due course. So if we can get a variable from this box, then we can use it. So we've said it's optional. If we can get it, then we can use it. And that's the very basics of optionals. Now, normally, I wouldn't teach these this soon in the course, but I think it's safe, or it's safer, if I give you a tiny introduction now, so later on, you're not kicking and drowning in the water of all this code, and then suddenly I've introduced something called optionals, and you're like, what's happening? That's why I've done it now. So one final thing to do, let's make this equal to my name. And we should be able to print that out so you can see it works. So we've checked if that variable actually exists because it's optional. Okay, perfect. Let's move on. Here we go. This is one of the big topics. It's actually one of the main pillars of object-oriented programming called classes and objects. Now I'm going to break this down very simply for you. A class is simply a blueprint. And what does a blueprint do? It allows you to create multiple instances of itself. So you'd have a blueprint, you'd use that blueprint to create some objects. And you could create as many objects as you like. So if I had a blueprint for a Bugatti, I could create as many as I liked, even though I could only drive one. But maybe I'll give you one. Maybe, if you're a good programmer. So all of these Bugattis are the objects created from the blueprint. They're the objects created from the class. So just think, a class is the blueprint, and a Bugatti is an object. Right, let's see what that actually looks like in terms of code. Open up your playground, and let's debunk one of the most commonly struggled with subjects there is in programming. Let's create a class by simply typing class. It's that easy. This class needs an identifier or a name. Let's call it fast car. And open and close your curly braces. Notice a class does not have brackets because a class cannot be executed like a function can. Now, a class contains a bunch of variables or properties and a bunch of functions, whatever we need it to contain. So let's say we have this fast car and we give it a top speed of 155 miles per hour. So that's an integer. Right, let's say we wanted to get the middle speed of this car. Well, how would you do that? Well, we'd create a function and we would say get middle speed. And this function would take no arguments, but it will return perhaps an integer or perhaps even a float. Let's see what happens if you return an integer. And just to make it easy, let's make this 156. So, what are we going to return? Let's return 156 divided by 2. So, that should return. Now, there's something I should point out here. When you divide integers, there are no decimal numbers remaining. Just remember that. So, if you divided 155, you wouldn't have a 0.5. That's why I changed it to 156. And rather than having 156 here, I should actually say top speed divided by 2. That's my bad. Right, so that's a class. It contains a top speed property and it contains a couple of functions, perhaps one here to get our middle speed. Right now, it doesn't do anything by itself. That's important to know. So that's the blueprint. let's create an object. Var Bugatti is equal to fast car, and then we open and close brackets, and that will initialize it. So what that does is it gets all this code, creates the object of fast car, and assigns it to Bugatti. Right? So if we wanted to get out the middle speed, we could say Bugatti dot get middle speed. So whenever we create an object, it obviously inherits all of these things that come inside of the class or the blueprint. Right? So that's not all. We can create another car. We can say var Ferrari is equal to a fast car. And we've created a Ferrari. And we can get the Ferrari's middle speed if we so wished. And of course, it's the same because we've defined it. Right, so we can create millions and millions of objects if we want, all based off of a single class. And can you see how that's going to be really useful when we start to create our more complex programs? Having a class that defines a thing or a sort of subject that our app tackles allows us to organize our code in a very neat and precise way. Okay, so a Bugatti is actually faster than a Ferrari, but at the moment they both have the same speed, and we've got to correct that. The way we're going to do that is when we create the object in fast car, we're going to pass over a variable for the top speed, because they all have different top speeds. It's ridiculous to have the same one for all of them. This isn't the communism of cars, if you like. So the way we do that is by coming up to our class, and there's this very special function called init. And look at Swift, it says this is the initializer declaration. Now this is a function that fires whenever we make a new fast car. So inside of here, we can pass over a variable. We can say, I'm going to pass over top speed, which is going to be an integer. Right? So I've passed over top speed. How do I get this top speed into here? And more importantly, these are the same names. How come it's not getting confused? Well, it's not getting confused because it knows that this variable only belongs to this little bit of code. It's only within this scope. If I came down to my function here and I access top speed, that top speed corresponds to this one. And if I hover over it or click it, you'll notice how the top speed, right at the top, gets highlighted by Xcode, but the one in init doesn't. So that's important to know. So let's make this top speed equal to this top speed. The way we do that is by saying self. Self refers to the current instance of the class or the object we've just created. Self.topSpeed is equal to top speed. And trust me, Xcode knows what we are referring to. Now this top speed, we don't need to define it anymore. We can just say it's simply an integer. And we should be sorted. Now when we define our fast car, we actually need to pass over the top speed, which is maybe 210. And that works. And let's pass over the Ferrari. And maybe that's 155. Okay, maybe it's a bit faster, but let's leave it as is. So there we have it. Our middle speed for the Bugatti is now 105, which is half of 210. And the middle speed for the Ferrari is 77. Now remember when I said that integer error was lurking? There it is. 77 times 2 is what? 154. Where did the 1 go? That's because when you divide 155 by 2, it gives you 77.5. But because an integer can't handle the point, it just drops it. It doesn't care, doesn't give you a warning. So you have to watch out for that. Right, so just a little quick review, because this is quite complicated. You create a class as a blueprint. You create an object from that blueprint. Then that object can access all of the properties, all of the functions inside of the class. You can also pass over some variables into init, which fires every time you make a new version of that class. And then you can assign those variables into the properties of your class. So don't worry if you don't understand that right now. You don't have to, because we're going to use classes all the time. Everything in programming is done with classes. Inheritance. And I don't mean that a distant uncle has died and left you £1 million, although I wish that was the case sometimes. Anyway, inheritance. Imagine trying to write some classes for many different types of cars, coupes, trucks, etc. Can you imagine how much repeated code you'd have? Well, this is where inheritance is going to save your fingers and save your time. So open up a playground and let's see what inheritance is all about. Right, let's create a really simple class called car. And let's say let the number of wheels equals to 4. Now let's say we want to create a family car. So I could copy that and call this family car. And let's have let number of wheels of 4, but maybe we want to have let number of doors equal to 5 because it's a hatchback. I'm really good at spelling. Right, now can you see a problem here? We've repeated this number of wheels twice, and obviously that is not good. So we want to code in such a way as to not to repeat our code. So let's change this class perhaps to vehicle, let number of wheels equal 4. That's pretty reasonable. Most vehicles do have 4 wheels. Now, if I have a family car, I can remove this number of wheels, and I can say, I want the family car to inherit all of the stuff that comes from the class of vehicle. And how do we do that? Well, simple. Semicolon. Car. Not car. It should be vehicle. Vehicle. I must be getting tired. I need a coffee. Right, so that means family car absorbs all of the stuff in this class into itself. So let's see that in action. Let's say var my car is equal to a new family car. Fair enough, we have a new family car. But here's the beauty. We can have family car dot, we can have my car dot number of doors. And we'll get 5. We can also have my car dot number of wheels. And here's the big reveal. It picks up the number of wheels from here. So you can see how we've saved a bit of code. We only saved one line here, and it almost seems not worth it. Trust me, it's worth it. Later on, when you're programming, this will save you more than anything. Always inherit where it makes sense, and mostly actually where you can. Okay, that's all there really is to inheritance. You're just inheriting all the stuff from another class. There's no point in going into it further, because again, we are going to inherit every single day that we code apps. It'll just become a part of the landscape. So we have come to the end of this module. You've learnt some really good basic concepts in Swift 4 and most other programming languages for that matter. You've covered a lot here, but don't worry if it hasn't actually all gone in. Nothing goes in the first time. I know from bitter experience myself. It will with time and practice. Here's a little summary of what you just accomplished. You learnt all about variables, integers, strings, booleans. You learnt about loops going round and round, while, repeat, for, etc. You learnt about functions and how to organize your code. Also about classes and objects, blueprints, and things. We also looked at arrays, sets, and dictionaries, ways of storing multiple bits of data inside a single variable. We looked at if-else switch case to see what things were, how they were behaving, and to do specific sets of programming things to them if they were the value that we expected. We also looked at optionals, which is a great start. It puts you on a good standing for when you come to more advanced programming. And finally, we looked at inheritance, one of the things you'll come across pretty much every day. So once again, well done. You deserve a little break from learning now. Here are some fireworks to see you off.